Alright, this time I'll be doing differentiation, NCERT exercise 5.3, implicit function differentiation and derivatives of inverse trigonometric functions. NCERT exercise 5.3, okay, which is more important chapter, high weightage chapter, differentiation. They know it's very much required for both board exams as well as competitive exams, correct? Implicit function, we shall see what is an implicit function and how to find the derivatives of implicit function, and also we'll discuss the derivatives of inverse trigonometric functions one by one. What is implicit function? You see, a function of the type where f of x comma y equal to 0 is called as implicit function. Means x and y are present on the same side of the equation. If it is in the form of y equal to f of x, that is called as explicit function. Y is present on one side, x is present on other side, that's called as explicit function. If x and y are mixed up on the same side of the equation, that's called as implicit function. So, a function of this type, f of x comma y equal to 0, is called as implicit function. Finding the derivatives of implicit function is called as implicit function differentiation. In this case, what we do is we differentiate each term of the equation with respect to x and collect the terms with dy by dx and group the terms without containing dy by dx and write an expression for dy by dx. Of course, there is a shortcut method for competitive exams, dy by dx equal to minus fx by fy. Fx means differentiating the given function f with respect to x partially, keeping y as constant. And f suffix y or fy means differentiating the given function f with respect to y, keeping x as constant. That I am not going to use now. Okay. Anyway, it's useful for CET and other competitive exams. The shortcut method in terms of partial derivatives, dy by dx in terms of partial derivatives, that I won't be using to work out the problems on NCERT exercise. Okay. So this is about the implicit function differentiation. Finding the derivatives of implicit function is called as implicit function differentiation, and implicit function means where x and y are mixed up. X and y are present on the same side of the equation. Some of the examples are given here. Various examples for implicit function. So, equation of circle is this: x square plus y square plus 2x plus 4y minus 7 equal to 0 is an example for equation of circle, correct? Already you learned circles in first PU. The standard form of the equation of circle is what? X square plus y square plus 2gx plus 2fy plus c equal to 0. X and y are present on the same side of the equation. Sometimes it is not possible to separate x and y. X and y are mixed up so that it is not possible to express in the form of y equal to f of x. Function of the type y equal to f of x is called as explicit function. If you can write y as a function of x, y as a function of x, it's called as explicit function. This is explicit function. Okay, y is present on one side, x is present on the other side. Y equal to x square, y equal to sin x, y equal to x cube minus 3x square plus 4x plus 7, like that. All those things are explicit function. This is implicit function. See, x cube plus y cube minus 3xy equal to 0. X and y are present on the same side of the equation. It is not possible to separate x and y in most of the time. Okay. X square plus xy plus y square minus 100 equal to 0. X log y plus y log x equal to 10. X sin y plus y sin x equal to pi. All these things, various examples are shown. And this is a general second degree equation. This is called as ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. It's called as general second degree equation. Various examples are listed out here, okay, for implicit function. And some of the important note is given here, how to differentiate a given function with respect to x. If it is x square or if it is y square or y cube with respect to x, the variable with respect to which you are differentiating also matters. See, derivative of x square with respect to x is 2x. The variables are same, correct? So differentiating x square with respect to x, same variable x. So derivative of x square with respect to x is 2x. Derivative of y square with respect to x is 2y into y dash, or I can write 2y dy by dx. See, derivative of y square with respect to x means 2y, differentiate this as a differentiate x square. Derivative of x square is 2x. Derivative of y square is 2y into further differentiate y with respect to x, that is y dash, or dy by dx I can write. 2y dy by dx. Derivative of y square with respect to x is 2y into dy by dx, or 2y into y dash. Likewise, derivative of y cube with respect to x. Derivative of x cube with respect to x is 3x square. Derivative of y cube with respect to x is 3y square into y dash. 3y square into dy by dx. 3y square into dy by dx. Correct? Or 3y square into y dash. Derivative of root y with respect to x, 1 by 2 root y into derivative of y with respect to x, which is y dash, or dy by dx you can write. Y dash is nothing but dy by dx. Derivative of log x with respect to x is 1 by x. Derivative of log y with respect to x is 1 by y into derivative of y with respect to x, which is y dash, or dy by dx. Derivative of sin y is cos y. Correct? Derivative of sin y with respect to x is cos y into derivative of y with respect to x, it is y dash. Correct? Learn all these things. How do you differentiate sin y with respect to x? Derivative of sin y is cos y into derivative of y with respect to x, dy by dx. Derivative of e power y is e power y into derivative of y is y dash. Correct? Derivative of e power x is e power x. Derivative of e power y is e power y into derivative of y, that is y dash. Derivative of cos y is minus sin y into y dash. Whenever you are differentiating y with respect to x, y dash comes. Correct? Derivative of sin x with respect to y is shown here. Differentiating sin x with respect to derivative of sin x is cos x. Suppose you're differentiating with respect to x. Now you're differentiating sin x with respect to y. So cos x into further differentiate x with respect to y, that is dx by dy into dx by dy. Derivative of log x with respect to y. Derivative of log x with respect to x is 1 by x. Now you're differentiating log x with respect to y. So 1 by x into further differentiate x with respect to y, dx by dy. Derivative of root u with respect to x, 1 by 2 root u into further differentiate u with respect to x, du by dx. Derivative of x cube. Derivative of x cube is 3x square. 3x square into further differentiate x with respect to u, dx by du. Correct? Here derivative of root u with respect to x, 1 by 2 root u into further differentiate u with respect to x, du by dx. Correct? Hope understand how to differentiate a function with respect to given variable. Derivative of x cube with respect to u. Derivative of x cube is 3x square into further differentiate x with respect to u, dx by du. Hope understand. Suppose I ask you to differentiate d by du of sin x. What is d by du of sin x? Derivative of sin x is cos x. Cos x into further differentiate x with respect to u, dx by du. Correct? Like this you should do. Suppose I ask you to find d by dy of sin t. What is d by dy of sin t? This is going to be equal to cos t into further differentiate t with respect to y, that is dt by dy. Correct? All these things you must be knowing. Derivative of sin t is cos t into further differentiate t with respect to y, dt by dy. So all these things, examples are given to make you understand how to differentiate a given function with respect to a given variable. Hope you understand. Please make a note of this. With this, I'll take the problems on implicit function differentiation. Is that clear? Any doubts? You can ask, you can text me, you can comment in the comment section also, you can give the comments. Okay. Derivative of e power y with respect to x, e power y into derivative of y with respect to x, dy by dx. dy by dx is indicated as y dash here. dy by dx is denoted as y dash. Understood? Now, find dy by dx of x minus y equal to pi. So, given equation is x minus y equal to pi. Given x minus y equal to pi. Differentiate this with respect to x on both sides. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. What we get? Derivative of x with respect to x is 1. Derivative of y with respect to x is dy by dx. Pi is a constant. Derivative of constant is 0. Hence we get dy by dx equal to 1. Quite simple question. Move on to the next one. Given x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. Want to find dy by dx. Here I am using the formula derivative of x power n. What is derivative of x power n? N into x power n minus 1, right? So given x power 2 by 3 plus y power 2 by 3 equal to a power 2 by 3. X power 2 by 3 plus y power 2 by 3 is equal to a power 2 by 3. Differentiate with respect to x on both sides. Differentiating with respect to x on both sides. Differentiating with respect to x on both sides. What is the derivative of x power 2 by 3? 2 by 3 into x power 2 by 3 minus 1. Derivative of y power 2 by 3 is 2 by 3 into y power 2 by 3 minus 1 into further differentiate y with respect to x, which is dy by dx. A power 2 by 3 is a constant. Derivative of constant is 0. Correct? Derivative of x power n is n into x power n minus 1. Derivative of x power 2 by 3 is 2 by 3 x power 2 by 3 minus 1. Correct? Using derivative of x power n formula. N into x power n minus 1. Derivative of y power 2 by 3 is 2 by 3 y power 2 by 3 minus 1. Further differentiate y with respect to x, dy by dx. A power 2 by 3 is a constant. Derivative of constant is 0. So from this, what we get? 2 by 3 into x power 2 by 3 minus 1, which is minus 1 by 3. This entire term shifted to right hand side becomes minus 2 by 3 into y power 2 by 3 minus 1 is minus 1 by 3 into dy by dx. So 2 by 3 is going to cancel, correct? So dy by dx is equal to how much from this? Dy by dx is equal to minus, you take that side, minus of x power minus 1 by 3 divided by, this will bring it to denominator, y power minus 1 by 3. Or I can write this as minus of minus y power minus 1 by 3, take it to numerator, it becomes y power 1 by 3. X power minus 1 by 3, bring it to denominator, becomes x power 1 by 3. So this is equal to minus cube root of y by cube root of x. Y power 1 by 3 is cube root of y. X power 1 by 3 is cube root of x. So what we get? Minus cube root of y by x. dy by dx is minus cube root of y by x. That's a solution. Move on to the next one. Hope it's clear. 2 by 3 minus 1 is minus 1 by 3. 2 by 3 minus 1 is minus 1 by 3. dy by dx equal to minus, take that side, x power minus 1 by 3 divided by y power minus 1 by 3. Y power minus 1 by 3 is taken up, becomes y power 1 by 3. X power minus 1 by 3 is brought down to denominator. To the power 1 by 3 means it is cube root. So cube root of y divided by cube root of x. Move on to the next one. Find dy by dx if 2x plus 3y equal to sin x. Given equation is like this. Given, what is given to us? 2x plus 3y is equal to sin x. Differentiate with respect to x on both sides. Differentiating with respect to x on both sides. Constant into variable. Constant keep as it is, differentiate the variable, correct? Whenever there is constant into variable, constant you write as it is, differentiate x with respect to x. 2 into derivative of x with respect to x is 1 plus 3 into derivative of y with respect to x is dy by dx. Derivative of sin x with respect to x is cos x. From this we can write an expression for dy by dx. 3 into dy by dx is equal to cos x minus 2. Correct? From this, dy by dx is equal to what? Dy by dx is equal to cos x minus 2 divided by 3. Cos x minus 2 divided by 3. Hence we get 3 into dy by dx is cos x minus 2, or dy by dx is cos x minus 2 divided by 3. Constant into variable means constant keep as it is. Differentiate x with respect to x1. Constant into variable. Constant keep as it is. Differentiate y with respect to x. dy by dx. Derivative of sin x is cos x. Correct? 3 into dy by dx is cos x minus 2. Or dy by dx is cos x minus 2 divided by 3. Hope you understand this. Differentiate each term of the equation with respect to x and find dy by dx. That's it. Move on to the next one. Given equation is like this. 2x plus 3y equal to sin y. Given 2x plus 3y is equal to sin y. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Constant into variable. Constant keep as is. Differentiate x with respect to x1. Constant into variable. Constant keep as is. Differentiate y with respect to x. dy by dx. Derivative of sin y with respect to x is cos y into dy by dx. Derivative of sin y is cos y into dy by dx. Correct? Constant into variable. Constant right as it is. Differentiate x with respect to x1. Constant into variable. Constant keep as it is. Differentiate y with respect to x. dy by dx. Derivative of sin y with respect to x is cos y into, further differentiate y with respect to x, dy by dx. Rearrange the terms. Take dy by dx common from this. What we get? 2 is equal to 2 into 1, 2. This is cos y into dy by dx minus 3 into dy by dx. So this is equal to dy by dx common. dy by dx is common. What you get is cos y minus 3. Correct? dy by dx is common from this. Cos y minus 3. So dy by dx is how much? 2 divided by cos y minus 3. Hope you understand. Constant into variable. Constant keep as it is. Differentiate x with respect to x1. Constant keep as it is. Differentiate y with respect to x. dy by dx. Derivative of sin y is cos y into dy by dx. So dy by dx common from this. Correct? 2 is equal to cos y dy by dx minus 3 dy by dx. dy by dx common. So from this, what we get? dy by dx is equal to 2 divided by cos y minus 3. 2 divided by cos y minus 3. Hope it's clear. Move on to the next one. Given ax plus by square equal to cos y, find dy by dx. A and b are constants, of course. Given equation is ax plus by square is equal to cos y. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Constant into variable. Constant keep as it is. Differentiate x with respect to x1. Constant into variable. Constant keep as it is. Differentiate x with respect to x1. Correct? Again, b is constant. Constant into variable means constant you write as it is. Differentiate y square with respect to x. Derivative of x square is 2x. Derivative of y square is 2y into dy by dx. Further differentiate y with respect to x. 2y dy by dx. Correct? Derivative of y square with respect to x is 2y into derivative of y with respect to x dy by dx. Derivative of cos y is minus sin y into dy by dx. Derivative of cos y is minus sin y into dy by dx. Further differentiate y with respect to x, dy by dx, correct? Derivative of cos x is minus sin x. Derivative of cos y is minus sin y into derivative of y with respect to x, dy by dx. From this we take dy by dx common. A into 1 is a, correct? This is shifted to right hand side, becomes minus 2by dy by dx. Minus 2by dy by dx minus sin y into dy by dx. From this we take minus dy by dx common. Minus dy by dx common. Minus dy by dx common. What you get is 2by plus sin y. 2by plus sin y, correct? This minus is shifted to that side, becomes minus a, and this will bring it to denominator of this right hand side. Dy by dx equal to, I can write this as dy by dx equal to minus a divided by 2by plus sin y. Minus is shifted to left hand side, it is minus a divided by, bring it to denominator, this is 2by plus sin y, correct? Derivative of ax is a into 1. Derivative of by square is b into 2y dy by dx. Derivative of cos y minus sin y into further differentiate y with respect to x, dy by dx. A into 1 is a. This will take that side. Minus 2by dy by dx. Minus sin y into dy by dx. Minus dy by dx common. What it means? 2by plus sin y. Minus you take that side. Minus a divided by 2by plus sin y, that is dy by dx. Move on to the next one. Find dy by dx if xy plus y square equal to tan x plus y. So given equation, differentiate with respect to x on both sides. Given xy plus y square, given xy plus y square is equal to tan x plus y, correct? Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. To differentiate xy, can apply the product rule or UV rule because it is product of two functions, correct? X into y. How to differentiate the product of two functions? First function keep as it is, differentiate the second function. Plus second function keep as it is, differentiate the first function. Product rule or UV rule we call. X into derivative of y, that is dy by dx, plus y into derivative of x is 1. First into derivative of second, x into dy by dx plus y into 1, correct? Applying product rule, x into derivative of y with respect to x is dy by dx plus y into derivative of x is 1 plus derivative of y square 2y into dy by dx. Derivative of y square is 2y dy by dx, correct? Derivative of x square is 2x. If you're differentiating x square with respect to x, it is just 2x. If you're differentiating y square with respect to x, 2y into further differentiate y with respect to x, dy by dx. Derivative of tan x with respect to x is secant square x. And derivative of y with respect to x is dy by dx. Differentiate y with respect to x, what we get is dy by dx. Collect the terms with dy by dx. Terms without dy by dx also separately write. So dy by dx is present in these three terms, correct? And this should take it to that side, to right hand side. This is shifted to left hand side. So what we get from this? X into dy by dx, x into dy by dx plus 2y dy by dx minus dy by dx is equal to secant square x minus y. From this we can take dy by dx common. Dy by dx is common. What remains? X plus 2y minus 1 is equal to secant square x minus y. Therefore, dy by dx equal to dy by dx is equal to what we get? Secant square x minus y divided by x plus 2y minus 1. Dy by dx is secant square x minus y divided by x plus 2y minus 1. Hope it's clear. Here apply the product rule. First function keep as it is. Derivative of y with respect to x dy by dx plus second function keep as it is. Derivative of x with respect to x1. Derivative of y square is 2y dy by dx. Derivative of tan x secant square x. Derivative of y with respect to x dy by dx. Collect the terms with dy by dx. I put tick mark here for the dy by dx terms. So dy by dx common. X into dy by dx plus 2y dy by dx minus dy by dx. Secant square x minus y. Take dy by dx common. X plus 2y minus 1. Secant square x minus y. So this is brought to denominator. Hope you understand this. Is that clear? Please make a note of this. Taking dy by dx common. X plus 2y minus 1 equal to secant square x minus y. Finally, we get dy by dx. We get expression for dy by dx. Secant square x minus y divided by x plus 2y minus 1. What is the next one? Find dy by dx of x square plus xy plus y square equal to 100. Write the given equation. Write the sentence. How to start? Differentiate with respect to x on both sides. Each term of the equation you differentiate with respect to x. Collect the terms with dy by dx. Group the terms without containing dy by dx. Then write an expression for dy by dx from that. Given equation is x square plus xy plus y square is equal to 100. Differentiate with respect to x on both sides. Differentiating with respect to x on both sides. What we get? Derivative of x square is 2x. To differentiate xy, I should apply the product rule. First into derivative of second, plus second into derivative of first. X into derivative of y is dy by dx, plus y into derivative of x is 1. Derivative of y square is 2y dy by dx. Derivative of constant is 0. Correct? Derivative of x square is 2x. To differentiate xy, product rule, x into dy by dx plus y into 1. First function keep as it is. Differentiate y with respect to x dy by dx plus second function keep as it is. Differentiate x1. Derivative of y square 2y dy by dx and derivative of constant is 0. Take dy by dx common here from these two terms. So dy by dx if you take common, dy by dx common, what we get is x plus 2y from these two terms. Dy by dx common. Y into 1y, take that side, becomes minus y. 2x also take that side, becomes minus 2x. Therefore, dy by dx equal to. Here you can take minus and common. Minus of y plus 2x divided by x plus 2y. Each term of the equation differentiate with respect to x. 100 is a constant. Derivative of constant is 0. Derivative of x square 2x. To differentiate xy, I am applying the product rule. First function keep as it is. Differentiate y dy by dx. Plus second function keep as it is. Differentiate x1. Derivative of y square 2y dy by dx. Whenever you differentiate y with respect to x, we get dy by dx. Correct? Then take dy by dx common here. Dy by dx common is what remains? X plus 2y. y into 1 y, take that side, minus y minus 2x, minus common, so minus of y plus 2x divided by x plus 2y. Important question found in many of the exams. Next one, find dy by dx for this. Sin square x plus cos square y equal to 1. Given equation is sin square x plus cos square y equal to 1. Given sin square x plus cos square y is equal to 1. Sin square x means sin x the whole square, correct? That is sin x the whole square. Cos square y means what? Cos y the whole square is equal to 1. Correct? Sin square x means sin x the whole square. Cos square y means cos y the whole square. It is of the type x square. How to differentiate sin x the whole square? Differentiate as you differentiate x square. Derivative of x square is 2x. Likewise, differentiate this. Derivative of sin x the whole square is 2 sin x into further differentiate sin x, which is cos x. Derivative of cos y the whole square, 2 cos y, further differentiate cos y, which is minus sin y, into further differentiate y with respect to x, dy by dx. Whenever you differentiate y with respect to x, dy by dx will be there. So differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of sin x the whole square is differentiate as a differentiate x square. Derivative of x square is 2x. So 2 sin x into derivative of sin x, which is cos x, plus derivative of cos y the whole square is 2 cos y into derivative of cos y, which is minus sin y into dy by dx. Derivative of 1 is 0. 1 is a constant, derivative of constant is 0. Understood? Derivative of sin x the whole square is of the type x square. Derivative of x square is 2x. Correct? So likewise, differentiate sin x the whole square, which is 2 sin x into derivative of sin x cos x. Cos y the whole square. Differentiate as a differentiate x square. So derivative of cos y the whole square is 2 cos y into derivative of cos y, which is minus sin y into derivative of y with respect to x, dy by dx. And we know 2 sin x cos x is sin 2x, the double angle formula. Correct? 2 sin x cos x is sin 2x. Sin 2x. Plus into minus is minus. 2 sin y cos y is sin 2y. Sin 2y into dy by dx equal to 0. So from this dy by dx I can write an expression. From this what we get? Sin 2x is equal to sin 2y into dy by dx. Sin 2x is equal to sin 2y into dy by dx. So from this I'll get dy by dx is equal to sin 2x divided by sin 2y. Sin 2x divided by sin 2y. Hence we get dy by dx is equal to so much. Sin 2x is equal to sin 2y into dy by dx, or I get an expression for dy by dx as sin 2x divided by sin 2y. Okay, make a note of this. Practice all the problems. Okay, it's quite important. Differentiation is an important chapter. It's a fundamental chapter. Move on to the next one. Find dy by dx if x cube plus x square y plus xy square plus y cube equal to 81. So given equation you differentiate with respect to x, each term with respect to x. Each term of the equation differentiate with respect to x. Then collect the terms with dy by dx. Group the terms without containing dy by dx and write an expression for dy by dx to get the answer. Given x cube, given equation is x cube plus x square y plus xy square plus y cube is equal to 81. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of x cube with respect to x, 3x square, correct? 3x square. To differentiate x square into y, I need to apply UV rule or the product rule because it is product of two functions. X square is first function, y is the second function. First function keep as it is, differentiate the second function. Plus second function keep as it is, differentiate the first function. Apply product rule here, UV rule. First function keep as it is, x square. First function write as it is. Differentiate y with respect to x, dy by dx. dy by dx plus second function keep as it is, differentiate x square, that is 2x, correct? To differentiate x square y, we are going to apply the product rule. First function write as it is, derivative of y with respect to x is dy by dx plus second function keep as it is, differentiate x square which is 2x. Coming to this third term, here differentiate x into y square, first function keep as it is, derivative of y square is 2y dy by dx, 2y dy by dx plus second function y square keep as it is, derivative of x is 1. Now derivative of y cube, last term, derivative of y cube is 3y square into dy by dx and derivative of constant is 0. 81 is constant, derivative of constant is 0. Understood? How to differentiate each term with respect to x. Derivative of x cube is 3x square. To differentiate x square y, I am applying the product rule. First function keep as it is, x square keep as it is, differentiate y with respect to x, dy by dx plus y into derivative of x square is 2x. First into derivative of second plus second into derivative of first. This much is done. Derivative of this is found here. Derivative of this, again apply the product rule for this because it is multiplication of two functions. Correct? First function keep as it is, derivative of y square 2y dy by dx plus y square into derivative of x is 1. Derivative of y cube is 3y square into dy by dx. Derivative of constant is 0. Take dy by dx common from these terms. dy by dx is present in these three terms. Correct? So dy by dx, if you take common, what do you get? dy by dx is common in these terms. What you get is x square plus 2xy plus 3y square. And these three terms shifted to right hand side. Y square take that side, becomes minus y square. 2xy take that side, minus 2xy. 3x square also take that side. So I'll get minus 3x square, correct? Shifting these terms to right hand side, minus 2xy minus y square. Therefore, minus sign I can take common from there. Therefore, dy by dx equal to minus of what we get, 3x square plus 2xy plus y square divided by x square plus 2xy plus 3y square. Hope you understand. Each term of the equation differentiate with respect to x and get the answer. Derivative of x cube 3x square. To differentiate x square y, I am applying the product rule. First function you write as it is. Differentiate y with respect to x, dy by dx plus second function keep as it is. Derivative of x square is 2x. To differentiate x into y square, first function x keep as it is. Derivative of y square 2y dy by dx plus y square into derivative of x is 1. Derivative of y cube 3y square into dy by dx. Is that clear? Then take dy by dx common from these terms. X square plus 2xy plus 3y square. Then minus 3x square minus 2xy minus y square. Minus sign common. And this you bring it to denominator. Get the answer. Move on to the next one. Find dy by dx if sin square y plus cos of xy equal to k. K is a constant here. Differentiate each term with respect to x, find dy by dx. As simple as that. Given sine square y plus cos of xy is equal to k. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Sine square y means what? It is sine y the whole square. Differentiate as a differentiate x square. Derivative of x square is 2x. 2 sine y into derivative of sine y cos y into further differentiate y with respect to x dy by dx. Sine square y means it is sine y the whole square. Sine square y means what? It is sine y the whole square. Differentiate as a differentiate x square. So what do you get? 2 sine y into derivative of sine y is cos y into derivative of y with respect to x dy by dx. Correct? Derivative of x square is 2x. Derivative of sine square y is 2 sine y into derivative of sine y cos y into dy by dx. Derivative of cos of xy is minus sine of xy into further differentiate xy by using product rule. Derivative of cos of xy is minus sine of xy into derivative of xy. To differentiate xy, apply the product rule. X into dy by dx plus y into 1. Correct? To differentiate xy, applying the product rule. First function x keep as it is. Derivative of y with respect to x dy by dx plus y into derivative of x1. Derivative of k is 0. K being a constant, derivative of constant is 0. 2 sine y cos y is sine 2y. So this becomes sine 2y into dy by dx. Sine 2y into dy by dx. Here multiply this inside. Minus sine of xy into x dy by dx. Minus x into sine of xy into dy by dx. Minus into plus minus y into sine of xy is equal to 0. Correct? Dy by dx common from this. Dy by dx is common. What do you get? Sine 2y minus x into sine of xy. Taking dy by dx common between these two terms. This term shifted to right hand side is equal to y into sine of xy. Therefore, we get an expression for dy by dx. Dy by dx is equal to y into sine of xy divided by sine 2y minus x into sine of xy. Derivative of sine square by 2 sine y into derivative of sine y is cos y into dy by dx. Derivative of cos of xy minus sine of xy into derivative of xy. To differentiate xy, I am applying the product rule. X into first function keep as it is. Derivative of y is dy by dx plus y into derivative of x is 1. 2 sine y cos y is sine 2y using double angle formula. Sine 2 theta we know. 2 sine theta cos theta, right? So 2 sine y cos y is sine 2y. Sine 2y into dy by dx minus multiply this inside. X into sine of xy dy by dx minus into plus minus y into 1y, y into sine of xy. Then take dy by dx common. Dy by dx common. Sine 2y minus x into sine of xy is equal to sine y into sine of xy. So dy by dx is y into sine of xy divided by sine 2y minus x into sine of xy. Clear, no? On to the next one. Find dy by dx if y plus sin y is equal to cos x. Given y plus sin y is equal to cos x. Differentiate with respect to x on both sides. Derivative of y with respect to x is dy by dx. Derivative of sin y is cos y into dy by dx. Derivative of cos x is minus sin x. Correct? Derivative of y with respect to x dy by dx. Derivative of sin y with respect to x cos y into further differentiate y with respect to x dy by dx. Derivative of cos x minus sin x. Then take dy by dx common from this. Dy by dx is common. Dy by dx, if you take common, we get 1 plus cos y is equal to minus sin x. Correct? Therefore, we get dy by dx equal to minus sin x divided by 1 plus cos y. Of course, 1 plus cos y is not equal to 0. Derivative of y with respect to x dy by dx. Derivative of sin y with respect to x cos y into further differentiate y with respect to x dy by dx. So that I can take dy by dx common. And derivative of cos x is minus sin x. So dy by dx is minus sin x divided by 1 plus cos y. Move on to the next one. Y equal to sine of log x. Prove that dy by dx equal to root of 1 minus y square by x. This can be done by two methods. Two different methods I can use. One way is I can rewrite this equation as sine inverse of y equal to log x. Sine inverse of y equal to log x and use derivative of sine inverse of x formula. Derivative of sine inverse of x is 1 by root of 1 minus x square. Okay. Derivative of sine inverse of y will be 1 by root of 1 minus y square into dy by dx. That method I can use. So rewriting this equation as sine inverse of y is equal to log x. Sine inverse of y is equal to log x. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of sine inverse of y is 1 by root of 1 minus y square into further differentiate y with respect to x dy by dx. And derivative of log x is 1 by x. So cross multiply, I'll get the answer. So dy by dx equal to root of 1 minus y square divided by x. This is brought to right hand side numerator. Root of 1 minus y square divided by x. Derivative of sine inverse of y is 1 by root of 1 minus y square into derivative of y with respect to x dy by dx. So dy by dx is root of 1 minus y square by x. This is one way of doing. Second method I'll teach you. Directly you can differentiate. Derivative of sine is cos. Cos of log x into derivative of log x 1 by x. That method. Second method. Given y equal to sine of log x, right? Y is equal to sine of log x. Differentiate with respect to x directly. Differentiate with respect to x on both sides. Derivative of y with respect to x is dy by dx. Derivative of sine of log x is cos of log x into derivative of log x is 1 by x. Correct? Derivative of sine is cos. Derivative of sine of log x is cos of log x into further differentiate log x. Derivative of log x is 1 by x. And you know cos theta is root of 1 minus sine square theta. Using that, taking the positive square root. Sine square theta plus cos square theta is 1, right? We know this identity. Sine square theta plus cos square theta is equal to 1. So I can write cos square theta is 1 minus sine square theta. Cos square theta is 1 minus sine square theta. So cos theta is what? Root of 1 minus sine square theta, taking the positive square root. Taking the positive square root. So cos of log x is, I can write it as square root of 1 minus sine square of log x. Cos of log x is square root of 1 minus sine square of log x divided by x into 1 by x is divided by x. This is equal to root of 1 minus sine of log x is y, no? Sine of log x is y. So sine square of log x is y square. So root of 1 minus y square divided by x. So dy by dx is root of 1 minus y square divided by x. Sine of log x is y. Writing cos theta as root of 1 minus sine square theta using the fundamental trigonometric identity. Using that identity and taking the positive square root, we get this. Move on to the next one. Root x plus root y equal to root 10. Prove that. Show that dy by dx plus root of y by x equal to 0. According to the question, given root x plus root y equal to root 10. Root x plus root y is equal to root 10. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of root x is 1 by 2 root x. Derivative of root x 1 by 2 root x. Derivative of root y is 1 by 2 root y into further differentiate y with respect to x. Dy by dx. And derivative of constant is 0. Root 10 is constant. Derivative of constant is 0. So from this, what do you get? 1 by 2 root x is equal to minus 1 by 2 root y into dy by dx. Correct? 1 by 2 root x is equal to, this will take that side. Minus 1 by 2 root y into dy by dx. 2 cancels. Cross multiply this. Root y go to that side. Numerator of LHS. Minus to take that side. Therefore, I get dy by dx equal to dy by dx. On cross multiplication, I'll get minus root y by root x. Minus root y divided by root x. Or I can write this as dy by dx plus root of y by x equal to 0. Root y by root x is root of y by x. Minus to take that, so they become plus. Hence we get the answer. Dy by dx plus root of y by x is equal to 0. Derivative of root x 1 by 2 root x. Derivative of root y is 1 by 2 root y into further differentiate y with respect to x. Dy by dx. Root 10 being a constant, derivative of constant is 0. And 1 by 2 root x equal to minus 1 by 2 root y dy by dx. 2 cancels. Cross multiply. Minus and also take that side. So dy by dx is minus root y by root x. Or root y by root x is root of y by x. Minus is taken to left hand, so it becomes plus. Dy by dx, shifting all the terms to one side, I get this. Dy by dx plus root of y by x equal to 0. Simple question. Okay. Move on to the next one. That is derivatives of inverse trigonometric functions. In this, there are the 6 inverse trigonometric functions. So I completed all the problems of implicit function differentiation of the NCERT exercise 5.3. Okay. Now we'll go to derivatives of inverse trigonometric functions. There are 6 trigonometric functions. Likewise, there are 6 inverse trigonometric functions. Sin inverse x, cos inverse x, tan inverse x, cot inverse x, sec inverse x, and cosec inverse x. These are the 6 inverse trigonometric functions we have. We're going to derive the formulas. We're going to derive the derivatives of inverse trigonometric functions. Already the table contains f of x, f dash of x, and the domain of f dash of x. This table is quite important. Even for MCQs, the questions can be asked based on this. Already in 2023 for Karnataka State Board exams, the domain of f dash of x was asked for sin inverse of x. What is the domain of derivative of sin inverse of x? It was a MCQ question. It's open interval -1 to +1. I'll reduce even the domain of the derivative. Okay, all these things I'll prove it one by one. By starting from y equal to sin inverse of x. Derivative of sin inverse of x is 1 by root of 1 minus x square. Derivative of cos inverse x is minus 1 by root of 1 minus x square. Derivative of tan inverse x 1 by 1 plus x square. Derivative of cot inverse x is minus 1 by 1 plus x square. Derivative of secant inverse x is 1 by mod x into root of x square minus 1. Derivative of cosec inverse x is minus 1 by mod x into root of x square minus 1. All the 6 formulas I'm going to prove one by one, and also I'll reduce the domain of the derivative of those functions. We'll start with y equal to sin inverse of x. We'll add one slide here to prove derivative of sin inverse of x. Let y be equal to sin inverse of x. Let y be equal to sin inverse of x. From this, we can write this as sin y is equal to x. Rewrite this equation. Sin y is equal to x. Y is equal to sin inverse of x. We know the principal branch of sin inverse of x is the closed interval minus pi by 2 to pi by 2. Means sin inverse of x will lie either in the first quadrant or in the fourth quadrant. That we know. So I am rewriting this equation. Y equal to sin inverse of x as sin y is equal to x. So differentiate with respect to x on both sides. With respect to x. Differentiate with respect to x on both sides. Derivative of sin y with respect to x is cos y into dy by dx. Derivative of sin y is cos y into dy by dx. And derivative of x with respect to x is 1. Derivative of sin y cos y into derivative of y with respect to x, dy by dx. Derivative of x with respect to x is 1. So dy by dx is 1 by cos y. Correct? Dy by dx. Dy by dx is equal to 1 by cos y. Correct? I can write cos y in terms of sine. The fundamental trigonometric identity, the Pythagorean identity we call. Sin square y plus cos square y is 1. Sin square y plus cos square y is equal to 1. So from this I can write cos square y equal to 1 minus sin square y. Correct? You know that sin inverse of x lies either in the first quadrant or in the fourth quadrant, because the principal branch of sin inverse of x is the closed interval minus pi by 2 to pi by 2. Correct? This is pi by 2. This is minus pi by 2. If x is positive, sin inverse of x will lie in the first quadrant. If x is negative, sin inverse of x will lie in the fourth quadrant. Correct? In the first and fourth quadrant, cos function is positive, right? So I'll take the positive square root here. Cos square y is 1 minus sin square y. From this, cos y is equal to, taking the positive square root of 1 minus sin square y. Taking the positive square root. Okay? Because cos y is positive in the first as well as fourth quadrant. Y is sin inverse of x, which lies in the first quadrant or in the fourth quadrant. Because the principal branch of sin inverse of x we know, the closed interval minus pi by 2 to pi by 2. Correct? So because sin inverse of x lies either in the first quadrant or in the fourth quadrant, means y lies in the first quadrant or in the fourth quadrant. So cos y is going to be positive. Hence taking the positive square root. And sin y is equal to x using this equation. Sin y is equal to x. So cos y will be root of 1 minus x square. Correct? Because sin y is equal to x. Sin square y becomes x square. So cos y we got root of 1 minus x square. So dy by dx is 1 by root of 1 minus x square. Correct? So derivative of sin inverse of x is 1 by root of 1 minus x square. And the domain of derivative of sin inverse of x is such that the terms inside the root should be positive or 0. But denominator can't be 0. Correct? So I'll take only positive value. So domain of this derivative is such that 1 minus x square should be greater than 0. Terms inside the root can be greater than or equal to 0 actually. But in the denominator, root of 1 minus x square is present inside the root, and that too in the denominator. Denominator can't be 0. Suppose this becomes 0, root 0 is 0, 1 by 0 is not defined. So I'll take only terms inside the root as positive. You don't take equal to 0 also, because 1 by 0 is not defined. So 1 minus x square should be greater than 0. So 1 is greater than x square from this. That is what I am getting is x square less than 1. X square less than 1 means what? X lies between minus 1 and plus 1. Correct? X square less than 1 means x should lie between minus 1 and plus 1. Learn the rules of inequalities. X square less than a square. X square less than a square means x should lie between minus a and plus a. Okay? X square less than a square means x should lie between minus a and plus a. So x square less than 1 means x lies between minus 1 plus 1. So domain of derivative of sin inverse of x is the open interval minus 1 to plus 1. Derivative of sin inverse of x is 1 by root of 1 minus x square, and the domain of derivative of sin inverse of x is open interval minus 1 plus 1. Don't write closed interval, because if you include the endpoints, derivative becomes undefined. Put x equal to 1, suppose 1 square 1, 1 minus 1 0, root 0 0, 1 by 0 is not defined, correct? Even if you put minus 1 also same story. So don't include the endpoints. Next I proved the derivative of sin inverse of x as 1 by root of 1 minus x square, and also I proved the domain of the derivative of sin inverse of x as open interval minus 1 plus 1. See, domain of derivative of sin inverse of x and domain of derivative of cos inverse of x is same. Open interval minus 1 to plus 1, okay, because denominator is same, no? So domain of derivative is same. 1 minus x square should be positive, because denominator can't be 0, so don't include 0. And root of negative is not defined, root of only positive number is defined, root 0 is defined, but denominator can't be 0, because 1 minus x square is present inside the root, and that too in the denominator, correct? So 1 by 0 is not defined, so we'll take only 1 minus x square as positive and solve the inequality. Same way you can prove derivative of cos inverse of x. Cos inverse of x derivative we should prove. Derivative of sin inverse of x is proved here. Now I'll prove derivative of cos inverse of x. Let y be equal to cos inverse of x. Second one. Let y equal to cos inverse of x. From this what you get? Cos y is equal to x. Cos y is equal to x. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of cos y is minus sin y into dy by dx. Correct? Rewrite the equation first. Y is equal to cos inverse x. From there we get cos y is equal to x. Correct? Rewrite the equation. Differentiate with respect to x. Derivative of cos y is minus sin y into dy by dx. Derivative of x is 1. So from this I am getting dy by dx equal to minus 1 by sin y. Minus 1 by sin y. And as I told earlier, using the Pythagorean triplet, Pythagorean identity, cos square y plus sin square y is equal to 1. Correct? So from this sin square y is equal to 1 minus cos square y. What is the principal branch of cos inverse? The principal branch of cos inverse is the closed interval 0 to pi. Means cos inverse of x lies either in the first quadrant or in the second quadrant. Correct? In the first and second quadrant we know sine function is positive. Cos inverse x range is 0 to pi. Correct? Cos inverse of x. Y equal to cos inverse of x lies either in the first quadrant or in the second quadrant. In the first and second quadrant, sine function is positive. So take the positive square root here. Sin y is equal to, taking the positive square root of 1 minus cos square y. And cos y is x. So this becomes root of 1 minus x square. Correct? So this is equal to minus 1 by sin y is root of 1 minus x square. So derivative of cos inverse x is minus 1 by root of 1 minus x square. So domain of derivative of cos inverse of x is same as domain of derivative of sin inverse of x. 1 minus x square should be positive. That means x square less than 1. X square less than 1 means that is x lies between minus 1 plus 1. Learn the rules of inequality. X square less than a square means x lies between minus a plus a. X square less than 4 means x lies between minus 2 and plus 2. X square less than 25 means x lies between minus 5 and plus 5. All those things you must know. Okay. Next, I'll deduce the derivative of tan inverse of x and cot inverse of x. And the domain of derivative for these two is same, that is R, the set of real numbers, because denominator is defined for every real number. Denominator is 1 plus x square. No, it gets defined for every real number, and x can be positive or negative or 0, whatever it can be. So it is defined for every real number. So domain of derivative of tan inverse of x is R. Domain of derivative of cot inverse of x is also R. So we'll derive the formulas for derivative of tan inverse x and cot inverse x. Third one I'm doing, let y equal to tan inverse x. Let y equal to tan inverse x. Rewrite this equation as tan y equal to x. From this, tan y is equal to x. Rewrite this equation. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of tan y is secant square y into dy by dx. Derivative of x with respect to x is 1. Correct? Rewrite the equation as tan y equal to x. Differentiate with respect to x on both sides. Derivative of tan y is secant square y into derivative of y with respect to x, dy by dx. Derivative of x with respect to x 1. So dy by dx equal to 1 by secant square y. Correct? 1 by secant square y. Secant square y is 1 plus tan square y, we know. Correct? 1 by 1 plus tan square y. Tan y is x from this equation. So this becomes 1 by 1 plus x square. Done. So derivative of tan inverse x, 1 by 1 plus x square. Same way I can prove y equal to derivative of cot inverse x. Let y be equal to cot inverse x. Let y be equal to cot inverse x. Differentiate, rewrite this equation. Rewrite this as what? Cot y is equal to x. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of cot y is minus cosecant square y into dy by dx, and derivative of x is 1. Correct? So from this dy by dx equal to dy by dx is equal to minus, to take that side, minus 1 divided by cosecant square y, and we know the identity cosecant square y is 1 plus cot square y. Correct? 1 plus cot square y. Cot y is x. So what we get is minus 1 divided by 1 plus x square. So derivative of cot inverse x is minus 1 by 1 plus x square. Correct? Y equal to cot inverse x. Rewrite the equation. Cot y equal to x. Differentiate with respect to x on both sides. Derivative of cot y is minus cosecant square y into derivative of y with respect to x, dy by dx, and derivative of x with respect to x1. So dy by dx is minus 1 by cosecant square y. Cosecant square y is 1 plus cot square y. So cot y is x. So minus 1 by 1 plus x square. Next I shall prove that derivative of secant inverse x and cosec inverse x, and also deduce the condition for domain of derivative. Y equal to secant inverse x you take. Let y be equal to secant inverse x. Rewrite this equation. Rewrite this equation. What do you get from this? Secant y is equal to x. Secant y is equal to x. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of secant y is what? Secant y tan y into dy by dx. Derivative of x with respect to x is 1. From this I get dy by dx equal to 1 by secant y into tan y. 1 by secant y into tan y. tan y to find out. Secant y is x. We know the identity 1 plus tan square y is secant square y. From there I can find what is tan y. We have 1 plus tan square y is equal to secant square y. So from this tan square y is equal to secant square y minus 1. Correct? So here the principal branch of secant inverse of x is the closed interval 0 to pi except pi by 2. That means secant inverse of x lies either in the first quadrant or in the second quadrant. In the first and second quadrant, what is sign for tan function? First quadrant, tan function is positive, and in the second quadrant, tan function is negative. So it can be either plus or minus. It depends. Correct? Once again, I repeat my sentence. Secant inverse of x is y. Y is secant inverse of x. Secant inverse of x can lie either in the first quadrant or in the second quadrant. Correct? Because the range of secant inverse of x is closed interval 0 to pi with an exception pi by 2. So y can lie either in the first quadrant or in the second quadrant. If y lies in first quadrant, tan y is positive. In first quadrant, every trigonometry function is positive. If y lies in second quadrant, in the second quadrant, tan y is negative. So when taking the square root, no, tan y is equal to, it can be either plus or minus. So plus or minus root of secant square y minus 1. Secant y is x. Secant y is equal to x. So what I am going to get is plus or minus root of x square minus 1. Correct? Secant y is equal to x. So plus or minus root of x square minus 1. So in the first, suppose y lies in first quadrant. In first quadrant, every trigonometry function is positive. Tan y is positive. Secant y is positive. Positive into positive is positive. Suppose y lies in the second quadrant. In second quadrant, both tan and sec are negative. So negative into negative is positive. So derivative of secant inverse of x is always positive. Remember that. So secant y is x, no? So this is equal to 1 by secant y is x, and tan y is plus or minus. I'll put mod for this. Mod root of x square minus 1. So this entire quantity is always going to be positive. Correct? So secant inverse of x can lie either in the first quadrant or in the second quadrant with an exception pi by 2. Correct? So y can lie either in the first quadrant or in the second quadrant. In first quadrant, both tan and sec are positive. In second quadrant, both tan and sec are negative. Negative into negative, positive. Positive into positive, positive. Negative into negative, positive. So this is kept positive. Okay. Plus or minus is absorbed with mod function, modulus of x. So derivative of secant inverse of x is 1 by mod x into root of x square minus 1. And the condition for domain of derivative is such that x should not be equal to 0. Because denominator can't be 0, and within the square root the term should be greater than 0. Actually greater than or equal to 0, but denominator can't be 0. Correct? So x square minus 1 greater than 0. That means x square greater than 1. X square greater than 1 means what? X is greater than 1 or x is less than minus 1. You must know this. So learn the rules of inequalities properly. X square is greater than a square means what? X square is greater than a square means x is greater than a or x is less than minus a. Learn this properly. If x square is greater than 4 means x is greater than 2 or x is less than minus 2. Okay. X square greater than 4 means what? I can write this as x is greater than 2 or x is less than minus 2. I am giving example to make you understand. Okay. If x square greater than 25 means x is greater than 5 or x is less than minus 5. So here x square greater than 1 means x is greater than 1 or x is less than minus 1. So x belongs to the interval minus infinity to minus 1 union 1 to infinity. Less than minus 1 means minus infinity to minus 1. Greater than 1 means 1 to infinity. So x belongs to this interval minus infinity to minus 1 union 1 to infinity. That is the domain of derivative of secant inverse of x. Secant inverse of x derivative is 1 by mod x into root of x square minus 1. Domain of derivative of secant inverse of x is the open interval minus infinity to minus 1 union 1 to infinity. It can be greater than 1 or less than minus 1. Finally, I go for cosec inverse x. We'll add one more page here. Y equal to cosec inverse x. Last one we have on this y equal to cosec inverse of x, and also I got some problems connected to this. We'll finish off this after completing the problems. Rewrite this as cosec y is equal to x. Differentiate with respect to x on both sides. Differentiate with respect to x on both sides. Derivative of cosec y is minus cosec y cot y into dy by dx, minus cosec y into cot y into dy by dx, and derivative of x with respect to x is 1. From this I can rewrite this as dy by dx equal to minus 1 by cosec y into cot y. Cosec y is x. So cosec y is x minus 1 by x into cot y to find out. 1 plus cot square y is equal to cosecant square y. 1 plus cot square y is equal to cosecant square y. So from this I can write it as cot square y is equal to cosecant square y minus 1. Correct? So from this cot y is equal to what? Cot y is equal to plus or minus root of cosecant square y minus 1. I'm taking plus or minus because the range of cosec inverse of x is the closed interval minus pi by 2 to pi by 2 except 0. Correct? It can lie either in the first quadrant or in the fourth quadrant. In first quadrant, cot y is positive. In fourth quadrant, cot y is negative. So plus or minus root of cosec y is x. So plus or minus root of x square minus 1. If y lies in first quadrant, every trigonometric function is positive. Cot y is positive. Cosec y is positive. Positive into positive is positive. Denominator is positive. If y lies in the fourth quadrant, cot y is negative. Cosec y is negative. Negative into negative is positive. So denominator is positive. So denominator is positive means I'll put mod x into root of x square minus 1. Plus or minus is absorbed with mod x. So mod x into root of x square minus 1. Both can be positive or both can be negative. So positive into positive is positive. Negative into negative also positive. Denominator is always positive. But derivative of cosec inverse x is always negative because minus 1 is already there in the numerator. So minus 1 by mod x into root of x square minus 1. And the domain of derivative of cosec inverse of x is same as domain of derivative of secant inverse of x. Cosec inverse of x, what derivative is here? Minus 1 by mod x root of x square minus 1. X not equal to 0 condition is there. X square minus 1 should be greater than 0. Means x is greater than 1 or x is less than minus 1. So domain of derivative of cosec inverse x is same as domain of derivative of secant inverse of x. With this I completed all the proofs of derivatives of inverse trigonometric functions and also deduce the condition. Please learn this table properly. Okay, it's quite important for MCQ. They can ask what is domain of derivative of secant inverse of x. Should be able to answer. Domain of derivative of cosec inverse x is also same. Open interval minus infinity to minus 1 union 1 to infinity. Please learn this table properly. Okay. And there are some problems connected to this. Learn all the double angle formula and triple angle formula. It's quite important to work out the problems on this derivatives of inverse trigonometric functions. Sin 2 theta, cos 2 theta, tan 2 theta, sin 3 theta, cos 3 theta, tan 3 theta. All these formulas are very important. Sin 2 theta, 2 sin theta cos theta equal to 2 tan theta by 1 plus tan square theta. Cos 2 theta equal to cos square theta minus sin square theta. 2 cos square theta minus 1 equal to 1 minus 2 sin square theta equal to 1 minus tan square theta by 1 plus tan square theta. Tan 2 theta is equal to 2 tan theta divided by 1 minus tan square theta. Sin 3 theta equal to 3 sin theta minus 4 sin cube theta. Cos 3 theta equal to 4 cos cube theta minus 3 cos theta. Tan 3 theta equal to 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Learn all these formulas to work out the problems based on this. Take up the problems now. Find dy by dx if y equal to sin inverse of 2x by 1 plus x square. Here I can make a substitution, put x equal to tan theta. Because 2x by 1 plus x square takes the form 2 tan theta by 1 plus tan square theta, which is sin 2 theta. Of course, I can write directly as 2 tan inverse of x and differentiate. But for board exams, you should do all the steps properly. So I am doing it in detail, all the steps. Put x equal to tan theta here. Put x equal to tan theta. So what do you get? Y is equal to sine inverse of terms inside the bracket is 2 tan theta divided by 1 plus tan square theta. 2 tan theta by 1 plus tan square theta is sine 2 theta. So this becomes sine inverse of sine 2 theta. Sine inverse of sine 2 theta is 2 theta because 2 theta will lie in the principal branch. Because I put x equal to tan theta, correct? X is between minus 1 to plus 1. So minus 1 less than tan theta less than 1, correct? So theta lies between minus pi by 4 and pi by 4. You know, tan inverse of 1 is pi by 4. Tan inverse of minus 1 is minus pi by 4. 2 theta will lie between minus pi by 2 and pi by 2, which is the principal branch, the part of the principal branch of sine inverse. Correct? Principal branch of sine inverse is closed interval minus pi by 2 pi by 2. But whenever we discuss the differentiability, we take the open interval. Hence open interval is given. This is also possible. I can write if it is true in closed interval, it should also be true in the open interval, right? So this is 2 into, substitute back for theta from this. Because we put x equal to tan theta, theta should be tan inverse of x. So 2 into tan inverse of x. Differentiate this. So far we are not differentiated. At this stage I am going to differentiate. Dy by dx equal to constant into variable. Constant keep as it is. Derivative of tan inverse x. 1 by 1 plus x square. So we get 2 by 1 plus x square. Move on to the next one. Find dy by dx if y equal to tan inverse of 3x minus x cube by 1 minus 3x square. Here I'll put x equal to tan theta, so that terms inside the bracket will be 3 tan theta minus tan cube theta by 1 minus 3 tan square theta, which is tan 3 theta. Correct? Put x equal to tan theta and proceed. Y is equal to tan inverse of 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Tan inverse of tan 3 theta is equal to 3 theta. Substitute back for theta. Because we put x equal to tan theta, theta is tan inverse of x. This becomes 3 into tan inverse of x. Differentiate with respect to x. Dy by dx equal to 3 into derivative of tan inverse x, 1 by 1 plus x square. So we get 3 by 1 plus x square. Answer. Move on to the next one. Find dy by dx if y equal to cos inverse 2x by 1 plus x square. Here also I'll put x equal to tan theta. Put x equal to tan theta, because we know 2 tan theta by 1 plus tan square theta is sin 2 theta. So this is y equal to cos inverse of 2 tan theta divided by 1 plus tan square theta. This is equal to cos inverse of 2 tan theta by 1 plus tan square theta is sin 2 theta. Cos inverse of sin 2 theta doesn't become 2 theta. To simplify this, I have to use the allied angles concept. Sin 2 theta I can write it as cos of pi by 2 minus 2 theta. Correct? Sin 2 theta, you can write it as cos of pi by 2 minus 2 theta. Sin is cos of 90 minus, using the concept of allied angles. So cos inverse of cos pi by 2 minus 2 theta is pi by 2 minus 2 theta. From this, theta is equal to tan inverse x. Theta is tan inverse x. So what do we get from this? Pi by 2 minus 2 tan inverse x. Differentiate this. Dy by dx. Dy by dx equal to pi by 2 is constant. Derivative of constant is 0. Constant into variable. Constant keep as it is. Derivative of tan inverse x. 1 by 1 plus x square. So we get the answer as minus 2 divided by 1 plus x square. Derivative of constant is 0. Pi by 2 is constant. Derivative of constant is 0. 2 into tan inverse x. Constant into variable. Constant keep as it is. Derivative of tan inverse x 1 by 1 plus x square. Correct? Derivative of pi by 2 is 0 because pi by 2 being a constant. Derivative of constant is 0. Constant into variable doesn't become 0. Constant keep as it is. Derivative of tan inverse x 1 by 1 plus x square. So minus 2 by 1 plus x square. Move on to the next one. Find dy by dx if y equal to cos inverse of 1 minus x square by 1 plus x square. Here also put x equal to tan theta itself because we know the formula. 1 minus tan square theta by 1 plus tan square theta is cos 2 theta. Orally we can do all these things, but still I am doing all the steps in detail so that it's helpful for board exams to write all the steps. Put x equal to tan theta. Y equal to cos inverse of 1 minus tan square theta divided by 1 plus tan square theta. 1 minus tan square theta by 1 plus tan square theta is cos 2 theta. Cos inverse of cos 2 theta becomes equal to 2 theta, assuming that it lies in the principal branch. Of course, for that condition it lies in the principal branch. You can verify if you want. Tan theta is x. So tan theta lies between 0 and 1, means theta lies between 0 and pi by 4. Correct? So 2 theta will lie between 0 and pi by 2. 0 and pi by 2 is a part of the principal branch of cos inverse. Substitute back for theta from this. Theta is equal to tan inverse of x. Correct? The conditions should be satisfied. Simply we can't write mechanically. Correct? Cos inverse of cos 2 theta will become 2 theta. If 2 theta belongs to the principal branch of cos inverse, which happens to be 0 to pi. Of course, it is part of the principal branch. Correct? See, tan theta is x. X is between 0 to 1 means tan theta lies between 0 and 1. Tan theta lies between 0 and 1 means theta lies between 0 and pi by 4. Theta lies between 0 and pi by 4 means 2 theta lies between 0 and pi by 2. 0 to pi by 2 is a part of the principal branch of cos inverse, right? So we can write theta is substitute back and differentiate this. Because we put x equal to tan theta, retrieve it back. Theta is tan inverse x. 2 into tan inverse x. Now differentiate dy by dx. From this, dy by dx is equal to constant into variable. Constant keep as it is. Derivative of tan inverse x. 1 by 1 plus x square. So this becomes equal to 2 by 1 plus x square. Move on to the next one. Find dy by dx if y equal to sin inverse of 1 minus x square by 1 plus x square. Here also I put x equal to tan theta only. So that 1 minus tan square theta by 1 plus tan square theta is cos 2 theta. Put x equal to tan theta. Y is equal to sin inverse of 1 minus tan square theta divided by 1 plus tan square theta. Correct? 1 minus tan square theta by 1 plus tan square theta is cos 2 theta. Cos 2 theta could be written as sin of pi by 2 minus 2 theta. Correct? Cos 2 theta is sin of pi by 2 minus 2 theta. Correct? The complementary functions, co-functions. Using co-function, I can write, or concept of allied angles I can tell. Sin of 90 minus theta is cos theta. So cos 2 theta is sin of pi by 2 minus 2 theta. From this we can write it as pi by 2 minus 2 theta. Substitute back for theta. X is tan theta. So theta is tan inverse x. Theta is tan inverse x. So we get this is pi by 2 minus 2 tan inverse x. At this stage we can differentiate. By simplifying, more simplification is involved. Differentiation is just last step. Only in the last step we are differentiating it. So more of simplification involved in these kind of problems. So at this stage we can write the sentence that differentiate with respect to x. Therefore dy by dx equal to derivative of pi by 2 is 0. Correct? Pi by 2 is constant. Derivative of constant is 0. Constant into variable. Constant keep as it is. Derivative of tan inverse x is 1 by 1 plus x square. So we get the answer as minus 2 divided by 1 plus x square. I am writing all the steps in detail so that it is helpful for you to attend the board exams. Okay. Of course, I can use a shortcut for CET and all. Directly we can write orally or we can do the mind calculations and the answer. but I am writing all the steps in detail. Okay. Move on to the next one. Question number 6. Find dy by dx if y equal to sin inverse of 2x into root of 1 minus x square. Condition is given that x lies between minus 1 by root 2 and 1 by root 2. Whenever there is root 1 minus x square, normally we make a substitution. Either put x equal to sin theta or cos theta. Correct? So here the condition is minus 1 by root 2 to 1 by root 2. For this condition we put x equal to sin theta. If the condition was given x to lie between 1 by root 2 and 1, in that case we put x equal to cos theta. Here we put sin theta and proceed, because this is a very standard problem in inverse trigonometry function chapter. Already we done. So here we put x equal to sin theta and simplify, and finally differentiate. Put x equal to sin theta. Given function becomes y is equal to sin inverse of 2, in place of x we put sin theta, 2 sin theta into root of 1 minus sin square theta. Correct? This is equal to sin inverse of, what we get, 2 sin theta into 1 minus sin square theta is cos square theta. Root of cos square theta is cos theta. Correct? Root of cos square theta is mod of cos theta. See, x is sin theta, no? X is lying between minus 1 by root 2 and 1 by root 2. Correct? X is what? Sin theta. So sin theta lies between minus 1 by root 2 and 1 by root 2. That means theta lies between what and what? Minus pi by 4 and pi by 4. Correct? Because sin inverse of minus 1 by root 2 is minus pi by 4. Sin inverse of 1 by root 2 is pi by 4. Now 2 theta I want. Correct? I want to find cos theta. I wrote 1 minus sin square as cos square. Root of cos square is actually mod of cos. Correct? Where does cos theta lie? Cos theta is positive, I can tell. Correct? Because theta is between minus pi by 4 and pi by 4. 0 to pi by 4 is the part of the first quadrant. Minus pi by 4 to 0 is a part of the fourth quadrant. So either in first quadrant or fourth quadrant, cos function is positive. Correct? So cos theta is greater than 0. So root of cos square theta is actually mod of cos theta. And mod of cos theta is equal to cos theta, because cos theta is positive. Correct? 2 sin theta cos theta is sin 2 theta. So this becomes sin inverse of sin 2 theta. Sin inverse of sin 2 theta is 2 theta. Retrieve back theta from this. Theta is equal to sin inverse of x. So this becomes equal to 2 into sin inverse of x. Now you differentiate dy by dx. Dy by dx equal to 2 into derivative of sin inverse of x is 1 by root of 1 minus x square. So answer is 2 by root of 1 minus x square. One important point I want to tell you here is, if you differentiate sin inverse of 2x into root of 1 minus x square, okay, I'm going to get the answer as 2 by root of 1 minus x square. If the condition is x to lie between minus 1 by root 2 and 1 by root 2. And if the condition is say 1 by root 2 to 1, the simplified form of this will be, is 2 sin inverse of x. Correct? For this condition, minus 1 by root 2 to 1 by root 2. If they ask you to differentiate sin inverse of 2x into root of 1 minus x square for the condition to x to lie between 1 by root 2 to 1, in that case it is minus 2 by root of 1 minus x square. Okay. The condition is if 1 by root 2 less than x less than 1. And in this case, for this condition, the simplified form of this is 2 cos inverse x. Okay. If x lies between 1 by root 2 and 1, simplified form of this is 2 cos inverse x, and derivative of that is going to be minus 2 by root of 1 minus x square. Two important things. Sin inverse of 2x into root of 1 minus x square, simplified form will be 2 sin inverse of x, and derivative is 2 by root of 1 minus x square for x to lie between minus 1 by root 2 and 1 by root 2. and sin inverse of 2x into root of 1 minus x square. Simplified form is 2 cos inverse x and derivative is minus 2 by root of 1 minus x square if x lies between 1 by root 2 to 1. For differentiability, we take the open interval. Of course, the inverse trigonometric equation may be true even for the closed interval. For differentiability, always we take the open interval, leaving the endpoints, because at the endpoints the derivative may not be defined. So we'll take only the open interval. Hope it's clear. Move on to the next one. Given, find dy by dx if y equal to secant inverse of 1 by 2x square minus 1. Here we make a substitution that put x equal to cos theta, because we have the formula 2 cos square theta minus 1 is cos 2 theta. 1 by cos 2 theta is secant 2 theta. Secant inverse of secant 2 theta is 2 theta. Retrieve back theta, then differentiate, get the answer. Put x equal to cos theta. Put x equal to cos theta. What do you get is y is equal to secant inverse of 1 by 2 cos square theta minus 1. Correct? This is equal to secant inverse of 1 by 2 cos square theta minus 1 is cos 2 theta. 1 by cos 2 theta is secant 2 theta. Correct? Secant inverse of secant 2 theta becomes 2 theta. Retrieve back theta from this. Theta is cos inverse x. So this becomes 2 cos inverse x. Now differentiate dy by dx. Constant into variable. Constant keep as it is. Derivative of cos inverse x is minus 1 by root of 1 minus x square. So answer is minus 2 by root of 1 minus x square. That's it. Hope I understand this. Because we have the formula for 2 cos square theta minus 1 is cos 2 theta, I am putting x equal to cos theta. So don't think that suppose I got sin inverse of 2x by 1 plus x square, we put x equal to sin theta. Outside sin inverse is there, put x equal to sin theta. Not like that. Depending upon the formula. Normally if 2x by 1 plus x square is there, we put tan theta. Outside if it is sin inverse or cos inverse, that does not matter. Depending upon the trigonometric formula what we have, based on that we make a substitution. Because we know 2 cos square theta minus 1 is cos 2 theta, I am putting x equal to cos theta. So 2 cos square theta minus 1 is cos 2 theta. 1 by cos 2 theta is secant 2 theta. Secant inverse of secant 2 theta is 2 theta. Substitute back for theta. Theta is cos inverse x. 2 cos inverse x. Differentiate. Constant into variable. Constant keep as it is. Derivative of cos inverse x is minus 1 by root of 1 minus x square. So we get minus 2 by root of 1 minus x square is the answer. Hope I understand this. With this we completed all the problems on derivatives of inverse trigonometric functions and also the implicit function differentiation. The problems connected to NCERT exercise 5.3 has been completed along with the concepts. Okay, also the proofs are given for derivatives of all the 6 inverse trigonometric functions, and also I explained the domain of derivative of those inverse trigonometric functions. Okay, and not taken the problems from the miscellaneous exercise. It will be done separately. Miscellaneous exercise of this chapter will be done in the separate video. In this session I discussed only the exercise 5.3 of NCERT book. This is helpful for board exams. Okay, I given enough knowledge of this exercise which contains both implicit function differentiation and derivatives of inverse trigonometric functions. Okay, many more videos will be uploaded in the coming days. I will be concentrating on NCERT syllabus for both first PU as well as second PU and KCET, NDA, JEE Main and many other competitive exams. Please subscribe to my channel and forward to your friends. With this, I conclude. Thank you.